All right, so on the review, I'm just going to quickly go through these questions and tell you guys how to complete the questions with the process shown. So if you had any concerns with any of them, hopefully this will clarify. So this first section here is asking whether the three sides that are provided will actually create a triangle. Remember, the way that you do this is you circle the biggest side in every situation. You're going to add the other two together and compare to that, the longest side by itself. So if you add 3 and 12 together, you get 15. And because the sum is equal to the individual side, that one's not going to be a triangle. All right, remember, we want the sum to be bigger than the individual side. For this one, if you add 16 and 17 together, you would get 33. 33 is less than 34, and so again, that would be a no, because remember, the sum needs to be bigger than 34. For this question, if you add 2 and 2, that's 4. 4 is bigger than 3, that's when you would say yes. All right, so those questions pretty straightforward. The next two questions are asking what the range of possible side lengths would be for the third side of a triangle if they've given you 2. So in each of these situations, they've basically given you a little triangle here. In the first scenario, they've given you 3 and 7, and they don't know what this side is, but remember, because we don't know what this angle is, it could be bigger or smaller. So we have two possibilities. We have the small end of the range and then the upper end of the range. So you guys would have something that represents the side length in the middle, whether it be an X or the actual name of the side. They could do either. That will be in the middle. And then to find the lower and upper parts of the range, you're just going to subtract and add. So if I do 7 minus 3, I should get 4, and if I add them, I would get 10. So remember, this should always be positive, so make sure you're subtracting the smaller from the larger. And so the side of the value could be anywhere between 4 and 10, not including those two numbers. Okay, so 5, 6, 6.5, 7.2, whatever. Over here, we're going to subtract those. So that would be 68. No, sorry. Adding, subtract first on the other side. Subtract on the other side first. So, I mean, if you added them together, you would get 62. Sorry, so I messed that one up. But this one would be 48 if I have my mental math correct. Yep. So if you subtract them, you get 48, and if you add them, excuse me, you should get 62. So, and again, it could be anywhere between those two numbers, but it doesn't include those two numbers. So if they ask for a range of possible lengths for a third side, this is what you do. This question is very similar to this one right here. It's just presented with a picture. So two planes are taking off from an airport. So they're going out like this, heading two different directions as modeled in the diagram. If plane A flew 200 miles from the airport and plane B flew 321 miles from the airport, what is the range of possible values for the distance between plane A and B? So that's this line right here. So remember, when they ask for a range of possible values, and notice how they're creating a triangle, we're going to do the exact same process that we did up here. It's going to be a range. So again, they could represent it with side AB or represent it with an X, but you're going to subtract on one side and add on the other. So if you were to subtract, you get 121, and if you add, you get 521. All right, so for that one, you can see that really it's the same kind of questions as the ones above. They just drew a picture and made it like a real world kind of scenario. So make sure you're looking out for those. This one says, given a triangle that they haven't drawn. So a really good idea is to go ahead and draw it for yourself. Then we have the measure of t is 50, the measure of r is 100, and the measure of y is 30. We are listing the sides of the triangle in order from largest to smallest. Okay, so remember, the largest side is across from the largest angle. So because this is 100, the largest side would be ty. The medium side is across from the medium angle, and so that's 50, so yr. And then the smallest side is across from the smallest angle, so tr. So that'd be your answer for that one. You have to draw the triangle yourself. This one is transitioning into our similarity. So we have these four-sided shapes here that are similar based on the directions. We're going to find the scale factor, solve for the missing values using the fact that they're similar. So the scale factor, remember, is just a fraction, first of all. And the way you find the fraction is by taking two corresponding sides that are just numbers, not variables, and writing them as a simplified fraction. So if you look here, let's see if we see 8 here. That's AB. AB corresponds to MN. Okay, so we can't use those because that has a variable. So you can draw 16. AD corresponds to MP, which is right here. Okay, so 16 over 20. That's the relationship between these two. But remember, you have to write it as a simplified fraction. So when you guys type that into your calculator, if you don't know, if you don't know how to do this in your calculator, I don't know if you guys, there we go. If you type in the fraction in your calculator, you get a decimal, and if you want to turn that into a simplified fraction, if you can't do it in your head, just go to math and then 1, and then it'll turn the decimal or fraction into a simplified fraction. So your scale factor would be 4/5. Or 5/4, depending on what direction you go in. Either is correct, because I didn't specify. But you have to make sure it's in a simplest form, sorry. All right, finding the measure of angle B. Remember, similar figures have congruent angles. Just like congruent triangles have congruent angles, so do similar. The only difference with similar figures is that their sides are proportional instead of congruent. But the angles are still congruent. All right, so I just need to figure out what corresponds to B, and then it's going to be the same. So if I look up here at the name, B corresponds to N is 120, so B is 120. However, when you guys are looking for sides, which is what X and Y are incorporated into with the picture, I have to use proportions. So if I'm solving for X first, I'm going to write the expression for X here, which is DC. DC corresponds to OP, 15. So I'm going to stack corresponding sides like this. And then I'm going to go use the scale factor, the two numbers that are just, I'm going to create a ratio with two sides that are just numbers instead of having variables. So that's the 16 over the 20 that we were using before. But again, I have to make sure I'm going from the same triangle as the x plus 3 to start. So I have 16 over 20 here. Okay, then I'm going to cross multiply. I don't know what that is. 240. Right, 20x equals 180, so it should be 9. So x equals 9. Okay. All right, then for y, I'm going to start with the y plus 2 expression. So mn corresponds with ab according to the name, so I would write 8 over that. And then again, I'm going to use the two sides that are just numbers. Now, notice how I'm going in the different direction, though. X started in this triangle, for y we're starting, sorry, not triangle, in this shape. And then for y, we're starting in this shape. So when I write the scale factor, now it has to be 20 over 16, because I'm going in the other direction when I write the ratios. So please make sure you write the ratios in the same direction when you write your proportion. Cross multiply, so 16y plus 32 equals 1600. Sorry, 160. I don't know why I said 1600. 160 minus 32 would be 128. Yep. And then that divided by 16 is 8. All right, so whenever you have similar figures, whether it's a four-sided figure or a triangle or whatever, you use proportions to solve when you're working with sides. All right, we're not going to worry about number 6. Number 7, this collection of questions is talking about whether triangles are similar or not. Remember, we have 3 different rules. So we could either use angle similarity, side similarity, or side angle side similarity. So we're going to test one of those 3. So for this one, I don't have any numbers on the sides. So I can rule out side, and side angle side, because I need numbers to actually use those. So the only one I can try is angle. It's not guaranteed to work, but that's the only one I can try. So I notice I have parallel lines, so I can use corresponding angles to get those equal and those equal, using the parallel lines and different transversals. So notice how I have a small triangle. If you want to do this, because this is a nested diagram, remember that's what I used to refer to them as, nested diagrams. So you can actually draw them separate if you want to. That might help you see how they have angle, because you have one set of congruent angles and then a second set of congruent angles. So yes, these are going to be similar. Sorry, they have to be similar. So angle similarity, and then again, we're going to name them correctly. So if I go CRN, then I have to go COB when I name the second triangle. Okay, this one again, it does not give me side numbers, so I don't know if it is proportional, because they haven't given me any numbers to work with. These triangles are actually congruent by side angle side, but we're not talking about congruency here, we're talking about similarity. So for these ones, we're going to say no for this one, because again, we would consider this congruent, and we're talking specifically about similar. So even though they have the congruency marks, they don't have numbers, so I can't actually check to see if they're proportional. So for this one, I'm going to say no. All right, we don't have any of the numbers to use to check to see whether these rules will work for those shapes. All right, for this one, we do have two sides and an angle in between them for each triangle, so the rule we're going to try is side angle side. I can't use side because I don't know the third angle. right? So what I'm going to do, whenever you're working with sides, you have to make sure you compare small to small, long to long. So in this triangle, the shortest is 4. And in this triangle, the shortest is also 4. This triangle, the longest is 7. And in this triangle, the longest is 6. If you put those in the calculator, those two numbers do not equal the same value. This ratio does not equal that ratio. So you would say no, right? The sides aren't proportional. I think on the answer key, I also just say that side angle side fails. That's another way that you can write it, but this is why side angle side fails. Either way is okay, but again, we practiced this form in class where you're explaining more in detail why the side angle side doesn't work. All right, so for this one, again, we're checking to see if they are similar. So I notice I don't have any angles provided, so I can roll out these two, but I do have all 3 sides per triangle. So I'm going to try side angle side. Now, sorry, side, side, side. When you guys are working with these triangles that have overlapping parts, right? Again, even though it's not a nested diagram, it still might be helpful to redraw them if you want. So I have the bigger triangle and then the smaller one like this. So I have 2.5, 3, and 3. And then I have 5 and then 6. And then notice this side right here is made up of the 2.5 and the 3.5. So I'm going to have to add those together, and that would give me 6 here. So again, I'm going to test to see if they're the same. I'm going to compare short to short, medium to medium, long to long. So the shortest in this triangle is the 2.5. The shortest over here is 5. Now the medium and the long are the same because these two are equal, so it really doesn't matter what order you write them in. But you'll notice that when you compare all these corresponding sides, they're all the same value. So you're going to say yes by side, side, side similarity, because the proportions are all the same for all the corresponding sides. And I'm going to name them correctly. So FA, all right, so FAL. And then when I come over here, I'm going to go FDE. For this one, it's a little vague, I'm noticing. Because it's isosceles, we're not exactly sure which one of these two base angles corresponds to these two because we don't have the angles in here to indicate. So I'm not going to take points off if you accidentally go EDF instead of FED because, again, they're base angles. We don't really know how they line up this way because we don't have any markings. So whatever direction you go in is fine for this because it's isosceles. All right, over here, I have the triangles are similar. I'm going to fill in the blanks based on the fact that they are similar. So they're basically asking us to find the corresponding sides. So they're starting with AB, which is the full length of the big triangle. This is a nested diagram, so you guys might actually want to draw them separate. In any scenario, if they're nested diagrams, it might be really helpful to redraw. So I have A, B, C, and then D, B, E. All right, so we're talking about AB. That clearly corresponds with DB in the smaller triangle. Then they have EB, which corresponds to CB. And then DE corresponds to AC. Okay, notice how I have all these sides up here are in the big triangle and all the ones on the bottom are on the smaller triangle. So I'm doing corresponding vertically. But remember, sometimes when they do proportions, which would just be 2 of them, they could do corresponding horizontally. We saw that on, I think it was either day 2 or day 3 that we talked about how you can write proportions in different ways. But just in this one, they want you to just match them up, going from one shape to the other vertically like that. This is a SOL type question that is multiple choice. So we know that R and U are congruent and we want to know which proportion is true. So they haven't given us anything else except for the fact that these two angles are congruent, but we can also conclude that these two are congruent because they're vertical angles. So with lack of information about the sides, we can't say that these are congruent triangles. We know that they're not congruent because we don't have enough information. But if you guys remember from this unit, one of the rules for similarity is just angle, angle. So even though we don't have enough to say that they're congruent, we do have enough to say that they are similar triangles. All right, so that's why they gave us proportions, because we can conclude that they're similar based on angle, angle. I'm going to work with the sides to see which sides are actually proportional. So in the first option, they're going from RT to US. So far that's looking good. They match up like this. and then they go TX to SX. All right, so that is also looking good. So option A is looking really promising, but remember for multiple choice, you want to keep going and see if you can definitely rule out the other three. So our next one is RX over UX. Again, that looks pretty good. And then we have RT to XS. So these two sides right here are clearly not corresponding, so we can rule out B for sure. RT over US, again, it starts out good, just like option A did. And then they go SXTX. So yes, these two sides are corresponding, but if you look really carefully, what happened here in this scenario, in the first proportion, I started in this triangle and I went over to this one. And then in this proportion, I went in this triangle over to this one. See how they switched directions? They went boom, 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 boom. But remember, we can't do that. For proportions, you need to do one ratio in the same direction as the other one. So this one went backwards, so that's incorrect because it didn't go in the same direction for both ratios. And then this one says XT over RX equals RT over UX. That's all really strange because they have three sides in one triangle and then just one in the other, and they don't even correspond. So that one's nonsense. So we've concluded that A is that correct proportion. Right? Number 10, what value of X would prove that the given triangles are similar? So remember, similarity is proportions. Every time we're working with similar, it's proportion. The sides are not equal. I know you guys are going to be tempted to do that because you're so used to that from Unit 4. But you can clearly see this one's bigger than that one. So we obviously know 4 and 8 are not equal, so these two can't be equal either. I know your temptation is just going to write an equal sign and solve, but you can clearly see they are not equal. Instead, they're proportional. So whenever you see similar, you have to think about proportion. So because we're solving for X, when I write my proportion, I like to start my proportion with what I'm looking for, and then I match it to what it's corresponding with. And then my other ratio is two sides that are corresponding. Now you have two options. You could either do 4 to 8 or 5 to 10. You'll notice that those both are 1/2 when they simplify, so it really doesn't matter. They're the same ratio. They simplify to the same thing. So you guys pick your favorite. I'm going to go ahead and use 4 over 8. And remember, go from this triangle to this one for the second ratio. I'm going to cross multiply. 28. I think this is a decimal. Let me just check really quick. Okay, 2.25. That's what you should get for X. To make them similar, we kind of assume that they're similar to begin with and kind of work backwards to see what X would get you there. And so we get X equals 2.25. All right, this is another one. We have similarity. That's what that little symbol means. They're telling us BAC is similar to GJH. Make sure whenever they give you the name, you use that because they give you the name on purpose so you can figure out what's corresponding to what. So we're trying to find the length of GJ. So I'm going to call that an X because that's what we're looking for. I'm going to start with that. So GJ corresponds with BA. So this side right here. So 7. And then 12, which is the only other number in this triangle, because I have to go back to this triangle to start the second ratio. HG corresponds with CB, which is right here, 8. So I cross multiply. I'm pretty sure this one's a decimal too. Let me just double check. Yeah, because this one is 84, and then you divide and you would get 10.5. Okay, so that's how you would do those. All right, this one right here is a word problem, but it's going to be similar again because we have two triangles here, right? That they'll provide this for you usually if it's a word problem without a picture, which I don't think you guys will have on here. Pretty sure they give you the diagram if they give you a question like this. But we know it's going to be similar triangles because we have one set of congruent angles right there and another set of congruent angles right there. So these two triangles are similar by angle. You need that first in order to actually use a proportion. So just double check to make sure that's the scenario here, which it almost always is, particularly in this chapter. So a surveyor makes a sketch for measurements he made along a river. So AB is 120. We're just going to fill in this diagram here. BD is 80. Oop, that's the wrong spot. BD is 80, and then CD right here is 40. we are trying to find the distance across the river from point A to point T, so that's this right here, so I'm going to call that x, all right? So similar triangles by angle, angle, I can solve for the sides using proportions. They're not asking about angles. Angles are congruent, but they're not asking us to do that. They want us to find sides, but sides are not congruent. I can't just say that this is 40 because that is, right? Because these are not congruent triangles, are similar. So I'm going to use a proportion. So I'm going to stack corresponding sides. So I have x, that corresponds with the 40 over here. And the other two sides I have are 120 and 80. I cross multiply. What is that? Just double check my work. Nope, not 2 zeros. Yes, 2 zeros. That's my bad. I typed in my calculator wrong. And then you divide it by 80. You should get 60. There we go. All right. And if you guys are wondering like how to actually go through once you get an answer, if you're curious about how to check your answer, there is a way you can do that. As you're going through your work and checking your answer, you can actually plug that in for x and make sure that this fraction is equal to this one. So let's say you wanted to check, you could do 60 divided by 40. You get 1.5, and then if you do 120 divided by 80, you also get 1.5. So you can double check in your calculator to make sure that when you find your x, it actually works with the proportion, and that's how you can verify that you were correct. All right, this one. Chris is measuring the height of a snow hill on the road. He stood 7 feet away. So the distance from the snow hill, I know it's technically from here to here, but the way that I do the triangle, we're just going to say it's that way, okay? So this little piece right here is 7. The snow's shadow and his shadow end at the same point, so that's right here. He is 5.5 feet tall. This is all in the same unit, so we can just write the number here. And then his shadow is 10. I'm trying to figure out how tall the mound is, okay? So remember, any kind of diagram like this, whether it has a weird kind of real life scenario kind of situation within the picture, it's still two triangles. Hopefully you guys can see that. We have the big triangle right here created with the snow pile and then going out like this. And then we have a smaller triangle created by the person going out like this. So remember, anytime you have a picture like that, whether it's just straight up triangles or triangles that you can imagine within the picture because of how it's set up with people standing or a tree or something, these are nested diagrams. Okay, when you have a smaller triangle inside of a bigger one, you have a nested diagram. So a really good idea is to draw the triangle separate. Ooh, I'm going to try that again. All right, so that's the big one. This will be the small one. Okay, so the big triangle is this full one right here. So the X represents that side. And then notice how this piece right here has been broken up into two parts, the 7 and the 10. So this whole thing is 17. That's why it's important to redraw the picture so you can see how that works with these two pieces added together. And then for the small triangle, 5.5 and 10. So once you do that, this question becomes super simple. You just have to write a proportion because we have similar triangles, and then go ahead cross multiply and then solve. So I have x over 5.5 equals 17 over 10. Remember, you have to go same triangle both ways. I cross multiply, so 10x equals 93.5, and then you're going to divide that by 10, and you get 9.35. Again, you can check to make sure that works with the proportion by plugging it in and double checking, and that's how you can check your work. All right, this is the same kind of setup. Hopefully you guys can see I have a big triangle right here, and I have a small triangle right here. Okay, whenever you have that situation, this is a nested diagram. So again, let's go ahead and redraw the triangles separate from each other. So I have the bigger one, oops, and then I have the smaller one like this, and I'm going to put the side measures in. So I know that this is 13. I know that, oh, this didn't print out very well. Oh, there's a bracket here, I think. Since it didn't print, I'm not 100% sure. But I'm pretty sure that the question has from here to here is just 26, like that. And then the small triangle, I have 8 and x. Now I know I have a 38 right here. I had a bracket that also had 38, which technically means that 38 goes here. But notice how I don't have this section in the small triangle. So I don't know what this side is. So you have to leave that blank. I'm not going to need these two sides, because you just need two corresponding sides per triangle. You don't need all three. So I'm just going to work with these sides and these sides because I have those two being corresponding. So you guys can ignore the 38 for now, all right? So the question says, we have these 3 people racing to get the last slice of pizza. How far does Nick have to run before he can get to the pizza? So they've already labeled that X. So that's what we're looking for. So again, once you redraw the triangles, very simple, straightforward. I'm going to write a proportion because they are similar. You can see one's big, one's small. They have that similar setup here. So X corresponds with the 26. So those get stacked. And then I'm going to use my scale factor, which is just using 2 sides, 2 corresponding sides from the triangles that are numbers instead of variables. So that's going to be my 8 and my 13. Okay, so then I cross multiply, so I have 13x equals 26 times 8, which is 208. And then you divide that by 13, and you are going to get 16. So x is equal to 16. Okay. Now, these questions on the geometric mean, remember the geometric mean is a formula I told you guys you had to memorize. It's a over x equals x over b. Oh, sorry, b. Why did I write 6? This formula you need to memorize. That's what you need to associate with geometric mean as a vocabulary word. X is the geometric mean. So we're trying to solve for x in this equation. They give you a and b in the question. So like here with the 6 and the 96, those are a and b. You're going to plug that into the formula and solve. So it would be 6 over x equals x over 96. And then you cross multiply the same way you would normally. So x squared is equal to 576. When you get a number that big, the first thing you want to try is see if that number is a perfect square itself. So if you take the square root of both sides, if you just do the square root of 57 in your calculator, 576 like I did here, I was just experimenting to see whether it's a perfect square or not. So I plugged that into my calculator and it actually is a perfect square. It gives you 24 even, right out of the calculator, no decimal. So if it's a perfect square, you can just write 24 and that would be your answer. It's not square root of 24. All right, you don't notice in here that it says square root of 24, it's just 24 even, okay? So when it's a perfect square, it comes out as a whole number. So you just make sure you write that down, circle it, and then move on. Okay, so we're going to do the same thing over here. So 5 over x equals x over 10. These two numbers go in the a and b positions. Cross multiply. And you take the square root of this, all right? Square root of 50 is not a whole number. All right, this can be simplified. So remember, you want to split this into 2 numbers where one of them is a perfect square, or the biggest one. So I can split this into 25 and 2. 25 is a perfect square. That becomes a whole number. And you take the square root of that. The square root of 25 is 5. So that number is going to come outside the radical, and the other number that wasn't a perfect square stays on the inside. So your final answer is 5 square root 2. All right, our last page here. So this is a bunch of questions just like we did on the very last day where I had all the different types of solving kind of mixed together in a little chart here. So you have to remember what kind of scenario is going on here, how you would solve it. Almost always it's just going to be writing a proportion. Oops. Oh, I got a lot going on my phone. What's happening? Okay, so you want to make sure you're looking at the picture, figuring out what kind of scenario you have. This is very faint. Hopefully you guys can see that. So for this one right here, I notice I have 2 triangles, all right? It'll either say in the directions or simply because we're working with similar triangles exclusively in this unit, I know that these triangles are going to be similar. So again, it didn't print out very well, but I think that because the x is so far out here, the whole thing is x no, actually it's probably, my printer doesn't print color and I think these were in color. So I think it looks like this. I'm pretty sure it would look like that. So for this scenario, when you guys are working with these triangles, I know they're touching. So if you wanted to, you could actually separate them if you can't see this very well to see that the full side is x plus 3. If this is indeed how it was labeled, which I'm not 100% sure. But the full side or full length here would be this part plus that part. So x plus 3. So if you want to redraw the triangle, maybe even just the one, you can see how it would be written when you're writing the proportion. And then this triangle would just be the 4 and the x. All right, so when you're writing the proportion, I'm going to go ahead and stack the corresponding sides again. So you can see, because they're both right triangles, you can use the linear pair to put the other right triangle here, or sorry, right angle. You can see that this side right here is the longest, and this side is the longest in this triangle too. So these two are corresponding, the x and the x plus 3. So I can stack those two. Now you can choose to write this however you want to, but once you write it one way, that kind of dictates how you write the next one. So I went from x plus 3 to x, so then I'm going to go from 7 to 4 when I write my second part of the proportion. Then I cross multiply, so 4x plus 12 equals 7x. I subtract that over, I get x equals 4. All right, hopefully this answer would be wrong if I labeled it incorrectly, so hopefully I got that right. If it doesn't, if I didn't use the correct labeling, then clearly this process would not get you to the right answer, the exact proportion wouldn't, but the process should be the same. Writing the proportion, cross-multiplying, solving. I'm just worried that because I can't see the symbols correctly, I have it incorrect, but hopefully that's what it should look like. This one is one of those unique situations we learned on day 4, I believe it was, when you have a single right triangle like this with an altitude drawn inside. This is when you guys have to choose between roller coaster or the Splash Mountain rule. So for this one, I noticed that the altitude is what's labeled instead of one of the legs. All right, if it was one of the legs, you would use roller coaster rule. If it's the altitude, that's when you use Splash Mountain. All right, so I'm going to write 2 over x equals x over 12. And then I'm going to cross multiply. So then I get x squared equals 24. Take the square root of both sides. This can definitely be simplified. 24 is the multiplication or product of 4 and 6. 4 being a perfect square. You can take the square root of that and leave the 6 on the inside. So you would get 2 squared root 6. And again, it's because the label was on the altitude as opposed to one of the legs that I knew to use the Splash Mountain rule. This one, however, again, this is another right triangle with an altitude drawn inside. So that's going to tell me that I need to use either Splash Mountain or the roller coaster rule. Because the altitude is not labeled, instead we have a leg that's labeled, that's when you use roller coaster. Right? It's either the altitude has a label on it or a leg has a label on it. So for this one, this is roller coaster rule. So see how I highlighted this? All right, do that in either of the situations so I can see what I'm doing. Because this is roller coaster, I need to go as far away as possible. And I'm going to swing around, loop the leg, and then end at the piece closest to it. This is how you draw the roller coaster. So remember, the way you use this rule is you're going to do this part first. So the launch track for the roller coaster, which is the full length of the hypotenuse. I have a bracket, which is telling me the whole thing is 12. Do not do 12 plus x. Remember, we talked about this extensively. The x is this part. It's already been incorporated into the 12 because of this bracket. So this part is supposed to be the full hypotenuse, 12, over 10 equals 10 over x. That's how you use the roller coaster rule. 12 over 10 equals 10 over x. Okay? Cross multiply. 12x equals 100. This is going to be a decimal. 8.3 repeating. Like that. Okay? This one got cut off a little bit. It's drawn. But remember, this is side splitter. When you guys have 2 transversals and at least 3 parallel lines, right? Almost always 3. It's going to be cut up into 4 pieces like this. And the side splitter says that these 2 along this side are written as a ratio, which is equal to these 2 written as a ratio. So you can create a proportion with those 4 parts. I'm going to start with the variable, and I'm going to go this way. Right? I'm going to go in the same direction along each side. So x over 32 equals 27 over 24. That's the side splitter rule. Then you cross multiply. Oops. 24x equals, I have no idea what that is, 864. And then I divide that by 24, and I get 36. All right, so look out. Remember, side splitter is easy to spot when you have the 3 parallel lines. Okay? All right, this one, again, my markings did not show up very well, but hopefully you guys can see it in your packet. This ray right here that's cutting through the triangle, cut this angle in half. So this is that angle bisector rule. This is the one that I like to use, the river analogy. We have a river going through our triangle. Everything on one side of the river is going to be proportional to everything on the other side of the the river. So this kind of splits the triangle. It doesn't split the triangle in half. Remember, it only splits the angle in half. So you need to have these little congruency marks in order to use this rule. So if the angle's bisected, that means these two are equal to those two. And I went like in this direction, so you have to go in the same direction in both sides. So x over 40 equals 9 over 10. And then I cross multiply, 360, and then divide that by 10. So ow, that hurt. 36. Pretty sure, yeah, because when you divide by, okay. So for this, and again, you could, anytime you're doing a proportion, if you're not sure whether it works, you can just stick it into the proportion and see if you actually get the same number for both sides. But again, you didn't need to use the 21 here, because the angle bisector rule doesn't use the actual length of the bisector. It only uses these two and these two. So you didn't have to use the 21 at all. It was unnecessary information. All right, here's another one where it is a right triangle with an altitude drawn inside. So I'm going to be using either Splash Mountain or Roller Coaster rule. And I actually have two variables in this picture. So I have to solve for one of them one at a time. So I need to figure out what rule to use for each of them and which one I would need to solve for first. So if I took a look at x, if I'm trying to solve for x, I'm going to pretend that y is not there. So I'm going to cover that up. If that's not there, you can clearly see that the altitude is what's labeled, not one of the legs, because I'm pretending that y isn't there. So in this situation, because the altitude is labeled and I'm trying to solve for x, I'm going to be using Splash Mountain. So for solving for x, I'm going to use Splash Mountain like this, because we're pretending y isn't there. So x over 4 equals 4 over 8, like this. And again, you cross multiply, so 8x equals 16, x equals 2, all right? So because we have two variables in this picture, it's really important that once you find one, you go ahead and put it in the picture, because it's probably going to be needed in order to solve for the other one. So now that we have x, right, now we can focus on trying to find y. I can't use the altitude to find y, because y is a leg of the big triangle. Remember, when you are given a leg, the label is on the leg, then you have to use the roller coaster rule. I understand that it's on both of them, but we already used the 4. We used the 4 already to help us find x. So now we're going to pretend it's not even there, because we already used it. Now we're going to switch to the roller coaster rule to help us solve for y. So remember, you start as far away as possible. And we go like that when we draw the roller coaster. And so we're going to write the proportion. The first part is this right here, going from here to here, the launch track to get into the loop. So from here to here is both sections added together, which is 8 plus 2, which is 10. So that comes first. So 10 over y equals y over 2, like that. Okay? Cross multiply, we get y squared equals 20. We're going to take the square root. 20 splits into 4 and 5, 4 being a perfect square, simplifies to 2 square root 5. All right, so that's how you find x and y when both of them are in the same diagram. If you had tried to solve for y first without knowing this, you would have gotten 8 plus x over y equals y over 2. And you can't have two variables in the same equation. It's just not good for you to try to solve. You can't find one of them without knowing the other. So in this scenario, you would have to solve for x first in order to solve for y. All right. For this one, we notice that we only have two parallel lines, so this isn't going to be a side splitter scenario. This is a nested diagram. So I have this scenario which shows me why the triangles are similar. They're similar by angle. So whenever you have this nested diagram with a smaller triangle inside of a bigger one, we're going to redraw it. Right, remember, side splitter is for 3 parallel lines. This is just 2 to show us why the triangles are similar by angle. I'm going to go ahead and redraw the triangles. So I have the slightly bigger one and then the smaller one here. So the bigger triangle is this full side right here, which is 10 plus y minus 2. Now you want to make sure when you're drawing the labels, if you can combine like terms, you want to make sure you do that. So if you have y minus 2 plus 10, that would really be y plus 8. Sorry, if you combine those like terms, because negative 2 plus 10 is 8. So when you combine like terms, you get y plus 8 on that side. And then over here, when you combine those two sides, you get y plus 12. to combine those two together to get the full length. And then for the smaller triangle, we just have 12 and 10. Right? So once you draw them separate from each other, we're going to go ahead and write a proportion. So again, match corresponding sides. So let's say I start with y plus 8, and you could start with the other one too. You could start with either of them, but I'm going to start over here. So y plus 8 over 10 equals y plus 12 over 12. Okay, I go from one triangle to the next one, and then I repeat that pattern. So I'm going to cross multiply. So 12y plus, it's escaping me right now, 96. And then 10y plus 120. I'm going to subtract this over here to get 2y. I'm going to subtract 96 over here to get 100. Nope, not 100. I am losing my mind. 24. There we go. And then y would equal 12. Okay, and again, you can plug that into the proportion to make sure that it makes sense, or you could plug it into the picture and make sure it makes sense, but that's the value that you should get for y. Excuse me. All right, now you guys do have a proof on the test. I don't have a list of options here on the review assignment, but there will be a little box with options that you can use to fill in the spots. But for proofs, it works the same way as congruent triangles. You're going to add the given information in the picture, figure out what you would need to prove that the triangles are similar, and then go into the proof and fill it out. So if I'm just focusing on this picture and the fact that GT is parallel to RD, I want to think about how I could prove that these triangles are similar, because that's what I'm trying to do here. So without even looking at the proof here, I notice that I don't have any numbers. There are no numbers on the sides whatsoever. So I can't use side, 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 or side, angle, side. The only other rule I could possibly use is angle, angle. So what I need to do is get two sets of congruent angles in this triangle to be congruent, and then I can prove that the triangles are similar. So I notice with parallel lines, I could say that these two are congruent because they are corresponding. I can also say that these two are congruent because they're corresponding. Right, so that would be one way to say that they're angle, angle. But you could also say that angle O is equal to itself because of reflexive. So I could use these two, I could use those two, I could use these two. Because you have three sets of angles that are congruent, there are multiple different ways that you can pair them up so you get angle, angle. So once you have this is plenty of information to prove that they're similar. We're going to switch to the proof to see what direction they want us to go in. So the first statement should always be your given. So I'm going to go ahead and write that down. So GT is parallel to DR. That was given. Okay, and then they tell us that TGO is congruent to RDO. We had that, right? That was something we added to the picture. So how did we know that? Remember, we knew that they were congruent because they were corresponding angles. So we're going to be using the corresponding angles postulate, because that's the rule that tells us that if lines are parallel, then corresponding angles are congruent. So the corresponding angles postulate is our reason for saying that they're equal. Now they chose to go in the direction of using the reflexive properties. So they chose not to mention these angles right here. Instead, they focused on this one. So remember, reflexive is when something's equal to itself because of overlap. So both the small triangle and the big triangle, and you can even see it in the name, they both have O in common. They both use angle O. So we're going to say that angle O is congruent to angle O itself. That's a reflexive property. And so with this set of angles and this set of angles being congruent, we can say that the triangles are similar by angle-angle similarity. Okay, so the proof on the test is just going to, you have to figure out which one of the three rules works, show why the information from the picture defends that, and then you're done with the proof. And then we have a couple of questions on here that are a review from previous units, so hopefully you guys remember how to do this. So this one says the complement of angle X is 55. They want to know what the supplement would be for that same angle. So in order to solve this question, you actually need to know what angle X is. And so that's why they gave you the first sentence. They said that the complement of angle A is 55. So complement is when they're complementary, like this, right? So one of them is angle X, the other one's 55. So in order to find the complement, I would do 90 minus 55 to find that X. So if I do that, I would get 35. So X is 35. Now they want to know the supplement of angle X, which you just found was 35. So remember, the supplement is what you need in order to get to 180. So if I know x is 35, what would I need to add on to that to get 180? Well, if you do some subtraction, you should get 145. So the answer to this question would be 145. We saw a question like that on the graded assignment. This is asking for the length of a segment that is defined by D and E, these 2 points. Remember, when they're asking for a length of anything that is from one point to another, this is the distance formula. You have to remember that when you see this word. Length from point to point is distance formula. So I'm going to plug that into the distance formula. So x minus x, because this is already negative, it becomes a plus. 3 plus 2 is 5. 5 squared is 25. 5 minus 7 is negative 2. Negative 2 squared is positive 4. The square root of 29 cannot be simplified, so we just leave it like that. Find the other endpoint of a segment if the midpoint is 4, 9 and one endpoint is negative 7, 2. So they've given you the midpoint already. So this is not midpoint formula. This is DMSE. They want to find the other endpoint when they give you the midpoint and one of the endpoints. So this is double the midpoint, subtract the endpoint that they gave you. All right, so I multiplied the midpoint by 2, and I'm subtracting the current endpoint that we know away from that. So 8 minus negative 7 is really 8 plus 7. And then 18 minus 2 is 16. So the point 15, 16 would be the other endpoint. And if you're not sure, remember the way you can check after DMSE is take this endpoint and that endpoint and do the midpoint formula and see if you get 4, 9. So that's the way that you guys can check. And then this last one here with the provided information, which would be true. So this is a fence question. Remember, they're asking which lines are parallel. So it could be these sets or none of them. So remember, for a fence diagram, what you want to do is fill out all the information on one side of the transversal and then look for corresponding angles. So I think we have more information on the top, so I'm going to go ahead and fill the top here. And the only way that you can do this is by using linear, pair, and vertical, because we don't know that the lines are parallel yet. The only way you can add information in that situation is by using vertical and linear pair. So I know that this is 111. Ooh, I didn't mean to do that. If I do linear pair with the 97, I get that. It's 83. If I do linear pair with this one, I would get 69. All right, let me just double check. Yep. And then linear pair here would give me 11. Linear pair here would give me 97. Okay, so now we're going to look to see what lines are parallel. So we're going to look for corresponding angles. So I see that I have two 69s and 111s that are congruent. So those are corresponding angles that are congruent. So I know that these two are going to be parallel. So let's see if we can rule out any. So the answer choice A doesn't have B and C, so I can rule that out. Answer choice B doesn't have B and C, so it has to be answer choice C. We also know that A and D are parallel because they have the corresponding 97s and 83s. Okay, so remember, that's how you work with the fence diagrams.